Hey all, so with this video we're starting a new chapter, and this one is factoring. Factoring is a really important skill that pops up all over the pre-calculus and calculus. You'll use it all the time in just kind of transitioning from one form of the problem to another form. Um, Very good skill to have in the toolbox. Brief intro to what factoring is. So it's kind of the reverse of multiplying. Oops, let me get my pencil going here. So normally for multiplying we go 2 times 3 and we get 6, right? Factoring is taking the 6 and saying what multiplies to be 6 and breaking it down into its primes, 2 times 3. So this is what we're doing for this entire chapter. It's all factoring, and we have a bunch of different styles to learn. And the first step for every factoring problem is to look for a greatest common factor. And so what a greatest common factor is it's the largest thing that divides into all of the terms of the polynomial that we're looking at. So we'd look at the numbers together and say, what's the biggest thing that divides into 5 and 45? In that case, we would say 5. So biggest number that goes into, oops, that was weird. Why did it do that? Okay, cool. So biggest number divides into the numbers. And then for the exponents, what we're looking for is the smallest exponent. So this one is actually x to the first, this one is x to the second, and so I can take out an x. The reason for that, we'll pop over to this one for a second as I explain it. If we think about 13y's, 8y's, and 3y's all sitting written side by side, I can take 3y's out of 13y's, but I can't take 13y's out of only 3y's. So that's where we're going to always look for the smallest power in the exponent, and that's going to be our greatest common factor. So back over here, we got 5x is the biggest thing that goes into both of these. And so we took a 5 out of a 5, so that would just leave a 1. We don't usually write the 1. I'm taking 1x out of 2x's, x squared, and so that would leave me x. And if we multiply back 5x times x, there's our 5x squared, and our plus. I'm going taking 5 out of 45, so I think 5 goes into 45 9 times, so that's what I need to have there. So when I go 5 times 9, I'm getting back to that 45, and then the x is right there. For this next example, and basically all of these are going to be pretty much the same thing, and again, it's super important to look for this when you're going to factor something. If you get the greatest common factor out of the way, it often becomes a pretty easy problem. When you're looking at it with the greatest common factor in the way, it looks really impossible as we get to some later styles of factoring in this chapter. So here we got 7, 5, and 3. Okay, there is no number, those are all primes, so there's nothing that divides into all of them, so there isn't a numerical greatest common factor for this one. But 13, 8, and 3, so that means I can take out the smallest power, which would be 3, and I'm just going to have this exact thing, but with all of these exponents as 3 less. So 7 y to the 10th is 3 plus 10 gets me back to 13, plus 5 y to the 8 minus 3 would leave us 5, and then minus 3, and then I don't need anything else there because y cubed times 3 gives me that minus 3y cubed back. Okay, for this next example, we have 10s, 4s, and 22s. So 4 doesn't go into 10, and so that makes me want to look at 2s next. I'm kind of starting with the easiest of the numbers, which is the 4. None of those are too terrible, but this has the least options. It's either 2 or 4. So it looks like my GCF is going to be 2 in terms of the number, and then 9, 8, and 6, and so I can take out 6. So 2 goes into 10 5 times, and 6 out of 9 would leave us 3, remember we're adding. And then 2 goes into 4 twice, and 6 out of 8 would leave us 2. 2 goes into 22 11 times, and 6 out of 6 leaves us none, which makes sense because we multiply back and get that. And you can always check any factoring by multiplying, so if you distribute this back, you should get the exact same you started with. 9, 15, and 3, so 3 goes into both 15 and 9, so that's going to be my greatest common factor. My smallest power in x is 4. and my smallest power in y is 2. So this should be 3, and then taking 4 out of 6, so that'd be x squared, taking 2 out of 3, so that would be a y. 3 goes into 15 5 times. 5 out of 4 leaves me x, and 2 out of 4 leaves me y squared. 3 out of 3, we could write a 1 there, but we don't generally do that. And then 4 and 2, oh, except for right now we do that, because if you notice, this right here is the greatest common factor. So if I multiply this back right now, this gives me the first term, that gives me the second term. So I need something there so that I get this back. And so when everything factors out like this one did, in that case you need that placeholder 1 so that if you distribute, you get that last term back. And then had that been a minus 3x to the 4th y squared, you would just have a minus 1 right there. For this one, let's see, we got 5s, so we get a 5 out front. 5, 4, 3, so x cubed. Y 5, 6, and 4, so y to the 4th is the smallest one. So 5 out of 10 leaves 2, x squared, and then y. 5 out of 5, so that took care of the 5. Looks like we'd have 1x left over, and 2 y's left over. And then for this one, we got the 5 and the x cubed, and the y to the 4th. And so again, this is the exact same thing. So I would just have a plus 1 there, so that when I distribute, that term comes back. These last couple, so we've been looking for greatest common factors that are monomials without a addition or subtraction going on in them. In this case, it happens to be the greatest common factor is a binomial. So it has addition and subtraction. It works exactly the same. If we thought of this as 14xy plus 9y, we would just factor that y out front and have 14x plus 9. This is going to work the exact same way, except instead of just a single term like this, it's this binomial. So we just take the x minus 6 out front, and it's going to leave us the 14x and the plus 9. And so if we're going to multiply this back, generally we would just FOIL, right? But we could think of this as x minus 6 times 14x, which is right here, and x minus 6 times 9, which would give us this piece. And that's actually just writing FOIL kind of as a more of a two-step process than doing the first outer, inner, and last, but it's the same thing. And then this next one's the same deal. So here the GCF is the 13t minus 7, so we'll just bring that out front. And it leaves behind the other 13t and then minus 8. And that's it, it's factored. So that's greatest common factor. Again, really not super hard, but really important to look for that as we go through the rest of the chapter.